take a glance at the clock, so say just before 20 after, if we can remember that. Are we on? Hello, Video Land Monday Morning Physics. We're talking about what we covered Friday, and we had an A note, and the frequency was 440 hertz. And the temperature of the air that the sound was traveling through was 25 degrees Celsius, and we were asked to find lambda. So lambda was the length of the waves. It turned out to be amazingly high to me. So let's just review how we got that. To find lambda, I see the two players of our team here. This one is the only one with lambda in it, which is wavelength. And which of these do we already know, MK? From this above, which one do we know? Frequency. So F takes on 440. I know it has 4 sig figs. I'm just not carrying them in my work, but I know it does. But I don't see either of these. I'm looking for this. So I'm going to have to go somewhere else. How many times do we do that? Hit a dead end and go somewhere else to find a piece of the puzzle. So I'm going to grab the other one. Was this the formula I gave you? And I couldn't remember. The 0.606. And then, all right, I couldn't remember. It was 355.1. I knew it was something like that. All right, so when you put in temperature, 25, what came out of this? Can you look so I don't have to tap it out, Zach? How many? What was the velocity? I didn't think I wrote it down.
347.
347. So now we go back and put it in here. Solving for a variable that's in the denominator mathematically. How do we get it up to solve it when it's in the bottom like that?
Multiply it.
Multiply both sides by it. It disappears from this side, appears in the numerator on this side, and then you can divide to isolate it. And when we did that, at the very end we end up dividing this number by this number, and lambda is 0.789 meters. So what's a meter? So 0.7 of it. It's a pretty long wavelength coming through the air with frequency, the A note. So they're not all little. All right, talking about frequency then, can you add just a note or two on there? It doesn't really fit on any other page, so I'll just make mention of it. Talking about frequency, the human ear can hear certain frequencies. It can hear as low as 20 hertz, so the human ear can hear as low as 20 hertz, and it can hear as high as 20,000 hertz. So that's what the human ear can pick up. So that's a pretty big range, but I was wondering if there are any ranges outside of those that we can't hear.
Is it 20,000 or 2,000?
What was that? Zero?
The
Yeah,
20,
it's supposed to be 20,000, I think.
Oh, I forgot the zero. Yeah, thank you. All right, so are there any outside of that we can't hear? And an answer is yes. And if you go below this, we call this infrasonic. There are waves below called infrasonic, and then probably the ones you've heard of more frequently are the ones above, and that's called ultrasonic. So the ultrasonics is where we get our ultrasound, which can even create images with sound waves. So just be aware of that. It didn't really, that kind of idea didn't fit in any other category, so I brought it out today. All right, let's try another one of these for your practice. You've seen me do one. Is this the only one we did?
Mm-hmm.
It is pretty much? Okay. So using these players, try this one. I'll give you the scenario. If you just write down the scenarios, calculate it so you can warm up your calculators. want you to find is frequency this time. And I'm going to say that the wavelength is 1 meter and the temperature is 15 Celsius. And I think that's all I need to tell you. These are the two that will get you where you need to go here. Does anyone need a push or where to start? If you start with the frequency formula, you'll see that it dead ends pretty quickly. So you're going to have to go somewhere else to find V. What is the value for the velocity? Did you get it, anyone? Brian, did you get this yet? The velocity put in here. What is that number? Not yet? Okay, Alex?
I didn't get it yet.
Okay. How about 300 what? 340.6?
I got 341.
All right,
Or
341.
340, I guess, because 266.
Which one, 340 or 341? 341? All right, so when we did that, 341, let's see what I got the other day. 341 rounding. So that's an easy one to plug back in. So when we plug 341 into here, we divide it by 1, and we get a frequency of 341 hertz. All right. Very good. All right, one more for the road, and then we'll change topics. I think you can handle these two equations. Let me do this one. I'll leave that one up. Over here, I want you this time to find T, which is, in this case, used to be period, but in this, what is it in this mod, Alex? What's T?
T.
It's not period this time. It appears.
Temperature.
Right, got it. All right, so we're going to find temperature this time. And we're given frequency 501, and lambda is 0.697. And go for it. Find temperature. Let me peek at your answer. I would be tempted to start here to find T because it has T in it, but I don't know V. So I have to go elsewhere and find V. Alright, so I'll drop you off there. I did work this one through. Looks like we're dealing with, well, addition in this problem right here causes us to be accurate to the tenths column. So when you add those two at the end, I don't know, I have to see how it works out. I know addition has different rules than multiplication for sig figs, so we'll trace this one through for once. See how it works. All right, did you get an answer? And, okay. I was very close to that. Okay. All right. Sorry, can't hear it here when that roars above my head. Can't hear myself, that's why it's motivation. Okay, you're still working?
Plant maybe.
Looking good there? All right.
It's really fun.
All right. Okay, and I will check on sig figs. I saw a whole range of sig figs, so let's see if we can remember what to do when we have to add. First of all, this is 3. And velocity is what we're looking for in this part. And lambda was 0.697. So we're working with 3 here. So did you get at that part, velocity is 349? All right. So velocity is 349. And then when I plug that back in here, that's what I got, velocity of 349. So I put it over here, and this is what I'm solving for. So, Alex, I saw you at that point. So
Yeah.
what happens, let me get rid of what's below, because we've used that, we don't need it anymore. So mathematically,
You get 29. Because you subtract 3.
right, you subtract. So that's the point. When you take 349 minus 331.5, that's what I wanted to remind you about sig figs, how they work. So addition and subtraction. Zach, what do you think?
I don't think you can use the 5.
All right, we can only be as accurate as the least column. So this is in ones and this is in tenths. So we can only be as accurate as the least precise of those columns. So we can, this is the ones column, this is the tenths, so we can only be accurate to the ones column. So when you subtract those two, what did you get? 29? No. I didn't write that step down. MD, what do you get when you subtract those two? Do you have it?
Well, I rounded up because it's 331.5, so it would be 332. So then you get 17.
Well, see that number.
Either
is,
way, you get 17 though.
Yeah, either way, it doesn't.
This number is actually infinitely accurate because it is in the formula.
Okay.
So you don't have to round it.
Okay, so
All right,
it's just.
so we can hang with it for a little longer. So what do you get when you get 349 minus 331.5? Try again. The calculator doesn't like that. Oh, there's a plus there.
This is me trying to do
17.5. So when we do this straight out, we get 17.5, and that's where we cannot use that 0.5. So it works differently. Like if we were using it with multiplication and division, which we usually do, it works differently. So we end up with 17 equals 0.606. Now we're back to regular sig figs, so it's only allowing 2 when we divide, and I got 30. So is that what you all got? I saw some 29s.
Well, when I did it, I just did 17 divided by 0.606, and I got 28.
Yeah, 20.9, that's what I got.
All right, using this amount of sig figs on this step.
Yep.
Mm-hmm. It's 17 divided by 0.606.
Okay, let me see. All right, 28. All right, so I'll go with that then. 28. 28 degrees Celsius. 2 sig figs after all. All right, I just wanted to bring that back to mind about the sig figs. All right, that's all I have to say about day 1. So, while we're talking about sig figs, let me hand back your tests, because here a sig, there a fig, everywhere a sig fig. There are little tiny sig fig errors throughout the test. And when I taught that, I think day 1 or day 2, I told you they would bug you the rest of the year. So,
Do you want me to turn it off?
yeah. All right, we will be back in a second.